Hello YouTube. We're going to be working on some probability and using discrete random variables to help tackle the probability problems. Random variables pretty much is like any letter or variable is going to represent something that will help us solve the probability problem. So if you roll a four-sided die, the outcomes are 1, 2, 3, or 4. If you roll it once, let x be the random variable equal to the sum of two numbers. So you don't roll a four-sided die, actually you'd have to roll twice. Roll a four-sided die twice. So there you go. So write out the sample space. The sample space again represents the outcomes, and that's represented by omega. So you could get you can roll a 1 and a 1 again. You could roll a 2, then a 1 again. You could roll a 3, then a 1, and you could roll a 4, and then a 1. I'm going to represent this line so the numbers aren't confused here. So kind of, it's kind of like a division line, just so you don't get confused. Then you could roll a 1 and a 2. Why isn't this working? You could roll a 1 and a 2. What the heck? Roll a 1 and a 2, 2 and a 2, and a 3 and a 2, and a 4 and a 2. You could also, this is going to be a lot of writing, so 1 and a, if you can't tell already, you could roll a 1 and a 3, 1 and a 2 and a 3. Yeah, I'm just going to write them all out. Hopefully you can see the pattern. Okay. So, those are all the outcomes if you roll a four-sided die twice. Now remember that x is the sum of the two numbers. So, if we're asked here to compute where x is less than or equal to 4, let's see what the possible outcomes is. Okay, so let's look at this. 1 plus 1 is 2, that's less than 4. 2 plus 1 is 3, that's less than 4. 3 plus 1 is 4, so that is equal to 4. 4 plus 1 is 5, so that does not count. 1 plus 2 is 3, so that is less than or equal to 4. And 2 plus 2 is equal to 4, that's less than or equal to 4. 2 plus 3 is 5, so that wouldn't count. And then we also have 1 plus 3 is equal to 4. All these other options here would be greater than 4. So that means if we have 1, 2, 3, 4, 5, 6 outcomes out of a total of, this is 16, because this is a 4 by 4, I guess you could even call it, yeah, never mind. It's 4 by 4, so 16 total. Then you have 6, why isn't this pen working? 6 out of 16. Wow. Okay, 16. This is bad. 6 out of 16. There. Ta-da. There you go. Next problem. Okay, sketch the PMF. This stands for the probability mass function. Pretty much it's just saying what are the possible values of x and what are the probability of those outcomes. So since x is the sum of the digits, so the smallest sum we could have here is 1 plus 1, which is equal to 2. So that means x would equal 2. Wow, this pen is like dying with digital ink somehow. And the maximum sum would be 4 plus 4, which is x equals 8. Okay, so that means we go from 2 to 8, so 2. Okay. So, when does x equal 2, or when does the sum of the two rolls equal the number 2? Well, that only happens here. It's the only time where the sum of the two rolls is equal to 2. So that's 1 out of 16. So then, what's the probability of rolling the dice where the sum is equal to 3? Well, that would only happen along this diagonal here. So that's 2 out of 16. Now what about 4? Well, that would be along this diagonal here. Okay, so the video was or was not recording when I had it intended to, so I'm going to go back a little bit. So again, the probability of rolling where the sum of the digits is 2 is 1 in 16, and that's shown here. For probability of rolling a 3 would be these two combinations, or these two outcomes, and that would produce 2 out of 16 possible. And same thing, the probability of rolling where the sum is 4 would be there, and that would be 3 out of 16. And if you keep following that path, you would get these results. So there you go. And if you notice the pattern, it goes 1, 2, 3, 4, 3, 2, 1. So now just we have to do a simple graph here. So the bottom here, or the x-axis, will be the x. So that will be this column here. So you just label 2 through 8, and then you can draw upwards like this, depending on the height. So this would be 1 out of 6, this would be 2 out of 16, sorry. This would be 3 out of 16, this would be 4 out of 16, then you would go 3 out of 16, 2 out of 16, 1 out of 16. We could put little dots here to show the points. And then you can label these, put them on the axes here, or you could just label it like this is 1 out of 16, this is 4 out of 16, 1 out of 16. You can label all these here. My digital ink is somehow running out, so I'm going to skip that portion. Okay, now you're going to sketch the CDF, and how this works really is, well, you add up all the possible, well, no. So it's showing the range of where the outcomes could be. So if you have when is x less than 2? Well, that never happens. But when is it between 2 and 3, let's say? Wow, this ink is horrible. Between 2 and 3, that would be 1 in 16th. Again, if it's between 3, including 3, and 4, not including 4. Wow, this pen, I am so sad right now. You simply add the previous. So if you look here, that this was 1 in 16, and then we have 2 in 16, so then it would be 3 in 16th. 3 in 16. Okay, same thing. If you go 4, oh my gosh, I'm so sad right now. 5. Then you add all the previous, so that means 3 plus 2 plus 1 is 5, and you do the same thing. Then the next one's going to be 4 plus 3 plus 2 plus 1 plus 3 plus 4 plus 3 plus 2 plus 1 plus 2 plus 3, like that. So I'm just going to write out the solutions to save time. Okay, there you go. Another pattern if you want to know. Pretty much, goes 2 through 8, and then all of these, except for the first one, are where it includes the digit, and this is where it does not include the next digit. Okay, so if you just want to put it on a graph, you put these on your y-axis here, and then you can put 2 through 8 on the x-axis. So I'll do that real quick, just the x-axis because I won't have room for the y. Okay, so here you'd have, start plotting your points. So when it would be 0 is not including, wow, this pen is so dying. I am so disappointed in it. No, oh my gosh. Okay, so that's not including 2. and it would go on in this direction forever, pretty much. It's negative probability, doesn't really make sense, but you get the point. Then, from this same probability, you go here, it goes to here, but this time it would include this point. And you keep going up, and this would be, going up the axes like this. It's just plotting, but I'll go into a little bit more on how to do it. And you go from here, so now you're including 3, and you go to 4, but you're not including 4. Wow. And then you go to 4, and you include 4, then you go to 5, and I'm just going to put ... and so on because of time. But these would correspond to the axes here, the probability. So like this one is down here is 0. This one would be 1 16th, and then 3 16th, but the ink is dying so it won't write. So you would just keep plotting it like that, and that's how you would graph the CDF. Okay, now it's asking you compute the expected value. Well, that's pretty much another way of saying the mean. And it's going to be represented as E of x in this question, but the formula for doing that would be this. So it's the sum of the random variable times the probability of that event happening. So I guess I'll just write the first few out and explain. Okay, this ink, I am so sad, but what you do is you take your x values, so we had 2 through 8, and then you multiply by the probability of that happening. And that's, for this one, you pretty much refer to this graph right here. And that's where we got the values. You just multiply all these across, and then you add them together. It's pretty much that simple. Same thing, kind of, if you asked to compute the variance, or v of x, you'd follow this formula. And mu, we're going to identify with this number here. I'm not going to compute it. But pretty much you can just write this entire formula, except the x values are going to be 2 through 8, so it would be 2 minus mu squared times the probability, which was 1 16th. Oh my gosh. This is killing me. I can't complete this. And then 2 minus, no, would be 3 minus mu squared times that probability, which was 2 16ths. And so on and so forth. So that's pretty much how you would just write that out and do the calculations, but unfortunately I will not be able to do that for you at this time, so you're going to actually have to do some thinking on your own. But that'll conclude this video. I wish I could say the end, but this, hey, now it's working for some reason. The end. That's the end of this video. I'm going to try to figure out how I can get some more digital ink, but good luck to you guys.